Find the first derivative of the function g of x equals x cubed, 8x cubed minus 12x squared minus 48x. So the derivative, we just use the power rule. So 3 times 8 is 24. Subtract 1 from our exponent. And then this would be 24x minus 48. Okay, find the second derivative of the function. The second derivative would be 48 minus, 48x minus 24. All right, evaluate g double prime of 2. So if I plug 2 into my second derivative that I just found, that would be 96 minus 24. And just so I don't make a mistake here, I think it's 72, but let's be certain here. Yep, 72. Okay. Is the graph of g of x concave up or concave down at x equals 2? Well, the second derivative is positive there, so that means we are concave up on that interval. Does the graph of g of x have a local minimum or a local maximum at x equals 2? Well, I think we're presupposing here that this is a critical number. We didn't verify that it was a critical number. We probably could pretty easily just by taking the first derivative, factoring it. Looks like I can pull out a common factor of 24. So that leaves me x squared minus x minus 2. And that would factor into x and x, 2 and 1. So that's a negative and that's a positive. So that means I have the critical numbers of x equals 2 and x equals negative 1. So it is a critical number, which is good because that's the only time we can be guaranteed that it actually is a minimum or a maximum. All right, so to determine which one it is, we can use the second derivative test. Since the second derivative is concave up on this interval, so if we're concave up, it looks like an upward facing parabola. And if we come across a critical number on that interval, it has to be a minimum. So this would be a local minimum.